Thanks very much for the introduction. I will indeed be talking about multitrack audio plugins and how they might be used in research and beyond. So by multitrack audio effect plugins or multitrack VSTs, I mean an audio effect that has more than the usual 2 or maybe even beyond the 8 inputs and outputs. Things I would like to convey during this talk is why you would want such a thing, as well as challenges that we've encountered creating those. So I guess by way of justification of my being here, I'm a PhD student at the Center for Digital Music, which is a music technology research group at Queen Mary University of London, just down the road. As music tech research goes, it's quite a large group with over 60 academics, postdocs, PhD students, and many of those have actually at some point, or maybe even currently, created VST plugins, and all of those actually, or at least all the ones I've talked to, have used JUCE to create those. Most, but not all of the people who have at some point created these VST plugins are from the area of audio engineering, so within music technology, which is quite a wide field, I suppose, and also a field that we're starting to call intelligent music production, in which I am active as well. So first off, why do we create plugins, and why are researchers interested in creating VSTs and using JUCE or something similar? So first off, the great thing about plugins is that it allows rapid prototyping of ideas, just validate a concept, testing algorithms, implementation of algorithms, emulating or I guess prototyping software that may later on become a standalone application, or even hardware can be modeled in the form of a plugin as well. And researchers specifically are often interested, or at least I am, and I know a couple of other people are, in collecting data from music producers and people active in music technology, and for this, compatibility with the existing commercially available digital audio workstations and other software is obviously a huge plus. Generally, and I think this goes for everyone, a plugin allows you to focus just on the processing, specifically created with JUCE, allows you to just focus on the processing, just on the DSP, which is really nice. Especially using JUCE, again, you don't really have to think about dependence on operating system and so on. You can just create it and it will basically work out of the box in theory. I guess the greatest thing about this is that you don't have to worry about anything that happens between the hardware input and the point at which it reaches your algorithm. You can just think about the DSP. And audio is in real time, which is also necessary for some applications, maybe with a live audio stream coming in and so on. And again, specifically in JUCE or something similar, the interface is very straightforward to make. You can make an interface in a matter of minutes rather than hours or even days, which is very great for researchers in particular, because we don't really care about interfaces most of the time. To speak on behalf of my colleagues who also use JUCE or who make plugins for the research, JUCE encourages good coding practice, makes our life a lot easier, and it's generally very well thought through, well integrated, and just great. So why would you ever want to make a multitrack audio plugin? First of all, if you're interested in some kind of cross-adaptive functionality where maybe the processing of track 6 depends on the audio features extracted from track 1, then such an architecture is quite hard to make unless you have a plugin that takes many inputs at the same time and maybe outputs a lot of audio streams as well. Some of these functionalities you might be able to make by clever sidechaining if your digital audio workstation supports it. but it requires a lot of setup and it's very limited, I guess. So that's another reason right there. If you want to model a larger system where, for instance, you have multiple audio streams interacting with each other, then a multitrack plugin is something you would need as well. For instance, let's say you want to make a emulation of a multitrack tape recorder and see how the different tracks bleed into each other or something, which I'm sure is a bad example, don't do that. But something like that, a VST plugin, would be useful as well. And the setup is just quite simple if you imagine just putting a plugin, in some situations at least, that you can just put on a multi-track bus rather than many different instances of the plugin on different tracks, then this type of architecture is also quite convenient. And finally, but maybe quite importantly, if you have spatial applications that are outside of the usual 5.1, 7.1 stereo sound, you might want a plugin to, for example, pan an object or a sound source between 20 different speakers or more, in which case this type of multi-track plugin architecture is also quite important. So I think this type of multi-track plugin could actually be relevant not just to researchers, but also developers, artists, and so on. I'm quite sure that whenever people give 3 examples and then say and so on, there's probably only 3 examples, but maybe someone can think of something else as well. I guess this covers basically everyone here. So this is just the theory. Allow me to maybe make my point a bit better by actually showing some of the work that we've done in the form of a multi-track audio plugin. So this is an example of what we call automatic mixing algorithms, and this is implementing automatic fader algorithm, which if and when a track is active, tries to put it at sort of equal loudness of other tracks, and you can do some more advanced things as well. Similarly, you can have an EQ like this one. This is an algorithm that checks for masking between all the different tracks coming in. Could be up to, I don't know, 100 or maybe more, and attenuates certain frequency bands to make other sources more audible and so on. It does a couple of other things as well. The automatic delay correction plugin is an implementation of a algorithm, again developed at Center for Digital Music, which if you have different audio streams, let's say there are different microphones at various distances from the same drum kit or piano, and it aligns them so that you don't get this comb filtering, which you get if there's delays between different audio sources. So this does that with near sample accurate, with sample accuracy. A bit more out there, someone actually made a listening test completely in a digital audio workstation using the different tracks coming in and then just making the interface very quickly in JUCE. I'm sure you could make a complete listening test in JUCE as well. I'm sure it's been done. And as a final example of this type of thing, a semantic compressor is an example of a semantic plugin which actually uses musical or semantic information embedded in the audio stream rather than the usual low-level features. And for instance, you could compress major chords more than minor chords if you would want to do that for some reason. Or if track 6 has drums, then maybe they're compressed differently if track 1, the piano, plays a different chord or is in a different part of the song and so on. So it's quite interesting as well. There's a couple of other examples of things that have been done at our group using JUCE. In this case, this is a Foley Designer, so basically it's a full application in JUCE, not a plugin, but it also has multiple streams of sensor data, which are sampled at audio rates, so I guess it's quite similar as well, to create Foley, so sound effects. The touch keys, if you're not familiar with them, are these little plates that you can stick on piano keys, and they sense where your finger is on the key. And it's not exactly an audio plugin, it's completely MIDI, but I guess it's multi-channel as well, because the way it deals with the vibration on the keys, not unlike the keyboard over there, is to actually make a separate MIDI channel for every voice. So I guess this counts as a multi-channel MIDI application. There's a lot of other things. I won't go into detail on that because I simply don't have the time. A lot of examples of non-multitrack plugins that are also interesting for research. One of them will actually be explained this afternoon in Sean Enderby's talk. So this is a project together with Birmingham City University, the Semantic audio feature extraction plugins. So at this point, I hope I've conveyed that there's at least a case for multi-track plugins in this type of architecture to do research, or maybe even other things. I'd like to hear your thoughts on that as well. But at this point, I'd like to discuss a couple of the challenges we've come across that are inherent to the development of multi-track audio plugins. So first of all, most digital audio workstations simply don't support it. There are only a couple of examples of digital audio workstations that have proper multi-track VST supports. Some of them obviously support 5.1, 7.1 mixing, and maybe up to like eight several channels per track. Notable examples that do support it, Reaper is one that we actually use quite a lot. It's rather open and very flexible. The routing options are quite extensive as well. And this is basically what we use all the time for running this type of multi-track plugin architecture. Another example, but this is less conventional as digital audio workstations go, is Audio Mulch. If you're not familiar with it, the nice thing about this is that you can actually visually connect the inputs and outputs of the different devices and plugins. Pro Tools is another case entirely. As you might be aware, it's not even possible for us to create a single track plugin because we're not really allowed to use the AEX SDK, so we're not able to develop this for research. Or to quote the audio plugin development program page on the Avid website, you must be willing to make your product available for commercial sale to end users. We don't offer our developer materials or services for academic use, experimentation, or, quote, just to check them out, unquote. So this basically excludes any kind of use within the academic environment, which is quite a pain in the neck because we're, as I said, quite interested in getting a lot of information from music producers and how they use their tools and so on. And when arguably still the industry standard, DAW, doesn't support that, then that excludes a whole group of potential users, which is quite sad. But compatibility issues aside, there's also a couple of other things that go with the creation of multi-track audio plugins. One of them is complexity. Obviously, when you have more tracks, your code will probably become a bit longer. So I find myself using a lot of these JUCE structures like heap block, which you might have come across, and owned array. Both of those are quite good for maybe creating a filter or whatever object for each channel and so on. And my code also includes a lot of these lines, so basically do this for every possible track. But with great complexity comes great CPU. So if you have a large number of tracks, supposedly your CPU load scales linearly with this, or maybe even worse when you've got interdependencies between all these different tracks, channels, and the cross-adaptive functionality of which I have shown a few examples. So for the first time, academics like me need to think about efficiency and making code that actually runs quite well, because if you've got code that runs at 2% CPU for a single track plugin, then if you've got 50 tracks, then obviously it's eating up all of your computer's resources. So efficiency actually becomes critical in this case, and basically you just have to code well. There's a couple of tricks that we can do, like here we were checking for which tracks were actually active, so is there anything going on in this track, in this window. And otherwise just ignore it, so that may or may not use your CPU load in some situations. But basically you just have to be mindful of good programming practice and making things efficient. A last challenge which I want to mention is if you do need interfaces that are sort of easy to use, the way I see this, there's two roads to go down to. So either you can make one large complex interface where you visualize all the features that you're interested in and all the parameters that you would want to control. This is actually not too bad because there's a lot of parameters that are the same for all tracks. But on the top row, you see all these. This is an automatic panner, by the way, so it pans the different channels depending on the, or tracks, I guess, depending on the frequency location, frequency information embedded in it. So basically, you have to scroll through all these sliders, which is not the worst, but it's one way to approach this. The other one being to make a different page, I suppose, for each track. So you, at any given time, you only display the features and the parameters of one track, and you just click which track you want to visualize. So at this point, I would just like to leave you with a couple of concluding remarks. First of all, I hope I've established that there's some unique opportunities in the multitrack audio plugin architecture, like audio streams that are cross-adaptive, processing that's interdependent, and basically just allowing complex architectures. But also a unique set of challenges that comes with it, most notably compatibility with existing software, DAWs, and also complexity, which obviously goes up when you do a lot of cross-adaptive stuff. As I'm sure you've noticed, or maybe you knew already, the focus of the average academic researcher like me might be quite different from those of industry folks, where we are quite often interested in just prototyping an idea, just getting a proof of concept out there, or maybe even collecting data from subjects. Whereas I would imagine a commercial plugin developer might also be very interested in computational efficiency and creating nice-looking interfaces. Although, as I've said a minute ago, computational efficiency does become a factor in some cases, obviously when you're researching a very efficient FFT or something, but also if you're just making very complex things that otherwise don't run on your computer, then that does become a factor. Interfaces are also important whenever someone else is actually using the thing you made, when it's not just you fiddling around with knobs. So those are two caveats right there. JUCE actually supports all of this, creating multi-track plugins with basically arbitrary track counts quite well, and as I said, enables very quick development in the academic realm, and I'm sure in the industry as well. I guess the problem is just with DAWs who don't natively support it. So if I am allowed to end on a slightly philosophical note, I do think that use cases, or I do acknowledge that use cases for multi-track plugins are quite limited, but I think there are a couple of instances in which it's nice to have this kind of architecture. And at the same time, I think support of this kind of architecture could really stimulate development, because right now it's just not an option, so maybe it's not considered at all. So on that note, I will happily scroll through some references and answer any questions you may have. Thank you very much.